Okay, this is video number 2 for 10.3, and we're talking about combinations, and we're kind of comparing them to permutations to build on something that we already know. And it's important to know permutations first, because combinations, like literally you take the formula for permutations and you just kind of add this little piece to it right there. And we're just going to talk about why that piece is important. Now we saw an example in the previous video. We're going to do another one. We're not going to list out all the different possibilities, but the other video had like less possibilities, only 20 and only 10. I wanted to look at one where there's significantly more. So let's take a look at this one. Find the number of ways to choose a first, second, and third place from 10 contestants. Okay, so the idea is you have 10 objects, which in this case are people, and you want to take them 3 at a time. You want all the different ways to arrange 3 people at a time from a bank of 10 people. Okay, so this is a 10 here, and this is a 3. So you'll see this like 10p3 or p of 10 and 3, right? That kind of idea. So this is a permutation idea because the order is important. So let's do it. We got 10 factorial over, and then we're going to do 10 minus 3 factorial. Okay, so this is 10 factorial over 7 factorial. Okay, which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 times 6 times 5 times 4 times 3 times 2 times 1. So we're going to cancel out the stuff we see on the top and the bottom. And really we just have 10 times 9 times 8. Well, 9 times 8 is 72, and then 72 times 10 would be 720. So there's 720 ways for this to happen. Okay. Now if you think about the fundamental counting principle, you have 3 choices, right? You have the choice for a first place guy, a choice for a second place guy, and a choice for a third place guy. And each one of those choices is an event. So there's 10 ways for the first event to happen, because you can pick from those 10 people. As soon as you pick a first place, though, there's only 9 people that you can choose from, and then there's 8 for third place. So that's kind of how this is how you rate this pattern for the fundamental counting principle. Okay. All right, I want to look at just one, we can't possibly list out all the 720 possibilities for this one, because that would take forever. But I want to list just some different orderings of the same 3 people, just so that will help us over here. Okay, so let's take 3 people. We're going to take Martin, Harriet, and Rosa. Okay, and we're just going to see what are all the different ways we can list just 3 of them. Now there's 10 people total, right? So just with one group of 3, now there's lots of different groups of 3, but just with one group of 3, how many different ways are there to do that? So we're going to do first, second, and third place. We'll just list them in order. So the first one will be first, second, and third. So we'll do it kind of like this. And I'm just going to use letters to make it easier. So we could have Martin in first, Harriet in second, and Rosa in third. Okay, we could have Martin in first, Rosa in second, and Harriet in third. Those are the different possibilities with Martin in first place. Okay, well let's look at the different possibilities that Harriet got first place. So you could have Harriet in first, Martin in second, Rosa in third. Okay, you could have Harriet in first, Rosa in second, and Martin in third. Okay, those are the options where Harriet is in first place. Okay, let's look at the options where Rosa is in first place. So you could have Rosa, Martin, Harriet, or you could have Rosa, Harriet, Martin. Okay, so how many different ways are there to order just 3 people? 1, 2, 3, 4, 5, 6. There's 6 different ways to do that, right? Which kind of makes sense, because how many different ways are there to order 3 people if order matters? There's 3 factorial ways to do that, which is 3 times 2 times 1, which is 6. Okay, so just in one group of 3, there's 6 different ways to arrange that, just a single group of 3. Okay, let's go over here and let's talk about the combination idea. Okay, I'm gonna erase some of this. Okay, Now what's going to happen here is we want the number of ways to choose 3 finalists from 10 contestants. So in this case, the order doesn't matter, right? In this case over here, if I had Martin, Harriet, Rosa, or Martin, Rosa, Harriet, that's the same group of finalists. The order doesn't matter over here as it does on here. Okay, so let's run through it and see what we need to do. Okay, now we're going to have we have n factorial, or 10 factorial people to choose from. So we'll write it out here, just like we did down here. So we want a combination this time. We have 10 people to choose from, and we're going to take them 3 at a time. Okay. Or we have 10 people to choose from. We want a combination where we take 3 at a time. Okay, and this is the formula we're going to use. So this is the number of people we have to choose from. It's typically objects, but that can be people or cards or marbles or whatever it happens to be. Okay, so 10 factorial over n minus r factorial. Okay, so that would be, we got 10 minus 3 factorial again. Okay, now this is the number of permutations that we would have, right? But the idea is we have way too many. If we do just all the permutations, we have all these duplicates, right? Over here, these duplicates are actually different scenarios. But over here, those 6 duplicates would actually all be the same thing. And so what we need to do is we need to add, or put in this secret ingredient here, the 6 factorial. So that's what's different here. We actually have that guy down here. And why? Or sorry, not 6 factorial. Excuse me. It's 6, but it's 3 factorial. Okay, so we need 3 factorial, which is equal to 6. Sorry. So we have n things to choose from, right? We have, this is n, this is r, this is r. Okay, so r is 3 and n is 10. So this part in black right here, this is how many permutations you're going to get if order matters. But the idea is you have way too many and we divide out the duplicates. Well, what's 3 factorial? 3 factorial is 6, right? Because there's 6 different ways to order any 3 people that you choose. Now this is just 3 of them, right? And we have 10 contestants, so there's lots of different ways to pick 3, and then there's all the orderings of those 3. So for here, we have to divide those out. So what that's going to give us here is 10 factorial over 3 factorial, 7 factorial, right? Notice, very, very similar. The only difference is this has the 3 factorial in it because that divides out the duplicates, okay? So that's going to give us 10 factorial, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So we're going to cancel out the 7s, the 6s, the 5s, the 4s, the 3s, the 2s, the 1s. Now just the top, 10 times 9 times 8, we know is going to give us 720. But now we're going to have 720 over 6. Basically, we're taking the 720 and dividing it by the 6 different ways we can order every 3 people. Okay, so this is going to be, if we want to cancel, we can say there's a 2 that cancels with the 2 in 8, right? Or 2 goes into 2 once, 2 goes into 8 4 times. 3 goes into 3 once, 3 goes into 9 3 times. Okay, so when we cancel everything, the 1 doesn't matter. 10 times 3 times 4. 3 times 4 is 12, times 10 is 120. So there's 120 combinations, but there's 720 permutations. If the order matters, there's 720 ways to do this. If the order doesn't matter, we take this number, divide it by 6, or divide it by 3 factorial, because that's the different ways you can order those 3 that you choose, and you get a smaller number. So there's going to be less combinations than there are permutations. And that's kind of, again, a compare and contrast. So this is old stuff. We've done this before. We know how to do this, and we kind of talked about why that's the case with the fundamental accounting principle. This formula takes the idea of permutations and then divides out the duplicates that you're going to have because order doesn't matter. So this r factorial represents all the different, the number of duplicates you're going to get for every group. Okay, so that's combinations versus permutations again.